people will we shall go through each. It won't take more time. Field level. Field level means field devices also we call it. Field devices generally inputs and outputs. In inputs, outputs, what shall we have? I think many of you know about this also. So let me show you very fast. In field devices, we have inputs and outputs. In inputs, we can have push buttons. Such kind of push buttons you have seen in your colleges also, I hope. Then we have selector switches, rotary or binary coded decimal switch, BCD switch. Then you can see we have sensors. When we talk about automation, in automation, we have more and more sensors. Sensors are also called automatic inputs. These three, push button, selector, and rotary, these are manual switches because a man operates it. But sensors are automatic inputs. Automatic inputs means a man won't operate it, but these will be operated by some objects, or we can say by some job. So in sensors also you have many types. Let it be what are the types. You can have inductive proximity sensor. You can have photo sensor, that is capacitive type. We can have reed switches. Reed switches are actually magnetic switches, magnetic sensor also you can say. These we use on pneumatic systems in mechanical department. You teach about hydraulic and pneumatic system. In pneumatic system, when we need to sense the position of piston, whether it is in final position or in home position, we use reed switches. I won't go in its detail, might be some other source person will tell you about this. Then you have a limit switch. We can have level switches also. In outputs, we can have indicators or lamps. We can have relays, and this is very important. In automation, in industrial automation, a relay will be used frequently, relay, contactor, then solenoid valve. This solenoid valve, in industry, we have pipelines also, right? Leaf pipelines. Obviously, in process industry, we have lot and lot pipelines. To operate its open and close, we have solenoid valve. And hydraulic and pneumatic system. In hydraulic and pneumatic system also we have pipelines for air and for that compressed oil in hydraulic system. So for that also we have pipelines, and there also we have solenoid valve. I hope mechanical people, you have seen this solenoid valve. So this is also output of PLC, or you can say this field device of automatic system. So this is the field level. In field level, we have inputs and outputs. Then it comes controller level. In controller, we can have different type of controllers. But in industrial automation, generally it is PLC, programmable logic controller. So PLC, we have, you can see these are a few pictures of micro PLC. That is compact PLC also you can say. Then you have modular PLC. So these are PLCs. In controller part, in controller level, we can have DCS also. Nowadays we have DCS also, distributed control system. But if you understand PLC, DCS is very easy to understand. Then PID is also a controller. PID, proportional integrated derivative controller. Proportional integration and derivation we have there. So PID, let me tell you about this. PID is one instruction also in PLC. So soft PID we call it. So PID feature you can use in PLC program, but in many applications in industry, hardware PIDs will be used. So these are controllers. These controllers take decision, you can make program for this, or you can do some settings. So in controller, you have seen, you have PLC, DCS, PID. Then it comes supervisory level. Supervisory level, where you monitor the things, you supervise the things. Supervisory level will have HMI, human machine interface, or we call it MMI also. Previously, we used to call it MMI, man machine interface. So human machine interface, you will have to supervise, monitor, and control. Then you will have SCADA, supervisory control and data acquisition. So here you can see the name is itself supervisory control. So you will have supervisory level. In supervisory level, you will have SCADA control room generally. About HMI and SCADA, we shall have more discussion tomorrow. So in any big industry, when you visit, you will have one control room where you will have SCADA system. That is your supervisory level of automatic industry. Then it comes planning, manufacturing execution system, MES. And if we talk simply about it, this is the group of people who are connected to engineering field and different level, like managers, or you can say engineers, or any person who is related to engineering on higher authority, that will come in planning level, and MES, manufacturing execution system. And then it comes the higher level. Higher level is your management, ERP, that is enterprise resource planning. So when you see the difference between these two, this planning level will have engineers on higher levels, and management level, mostly you can say the MBA people, management people. So they look after marketing and sales, everything they will look after. That will be management level. So we have 5 levels. Once more, I shall show you this pyramid. In pyramid, you can see we have field level. In field level, we have inputs, outputs, and in outputs, obviously we have motor, but motor we don't connect directly to PLC. So I have shown you there relay and contactors. And controller level, you have seen, you have PLC, DCS, PID. Then supervisory will have HMI, SCADA. Then you have planning and management. Okay, let it be. First of all, when I go towards programming part, I request you all people to have your notebook and pen with you. For 15 minutes, we shall have some discussion, theoretical discussion, and then I shall come to the programming part, and that will be very interesting. Programming part will be interesting, and we will have bilateral discussion. I shall give you some assignment, and you have to make that, you have to take photo, and you have to share in WhatsApp group. So we have to discuss the things while we do programming and all, but give me 15 minutes to have some theoretical discussion. It might be a bit boring because in also things which are doing are very important. In PLC programming, also some theoretical things you will have to understand. In PLC, some theoretical things you will have to understand. Might be it will be a bit boring, but very important. So firstly, let me go to the part that is PLC. We shall move towards PLC. But I shall start the discussion. See, these things you have already understood, right? In previous sessions. Type of automation you have understood already. These revolutions also, 1.0, 2.0, 4.0, you have understood all these things. So I won't go into that. I shall start my session from here. Controller. When we talk about controller, we need to understand few things about machine. Because basically, when your student will go to work in industry, or you also work in your college in some machine lab or on any system, you need to understand few things. When you see any machine, the machine would be very large, correct? The machine is generally very large. It is spread in large area also sometimes. We have not to be worried about the largeness of the system. That largeness is just a mechanical structure. Be very clear about it. Just a minute. Okay. So concentrate, please. So we have machines, and when we see one machine, it's very large, but we have not to be worried about the largeness. What would be your role in industry? Generally, maintenance. Most of time, it would be maintenance. But obviously, we have different work. Like sometimes you can go for project also. When you are in project side, then also you need to work on machine. When you are in modification side, then also you have to work on machine. So basically, we have to work on any machine. Suppose one machine is out of order, and this is sure that one machine will get shut down someday. It is sure. So when it is shut down, our task is to restart the machine in very short time. We can't keep the machine shut down for 1 hour or half an hour. In 5-10 minutes, you have to restart the machine. So try to understand the practical problem. When we see one machine, it's very large, and we don't understand from where we should start finding the issues, correct? This is the practical problem. If I take you to industry and I say this machine is not working, find the problem. Troubleshoot it. So what would be your first problem or confusion? The confusion would be the machine is having many things, many components in it. So from where have we to start finding the issues? We can eliminate this problem by a note option we have here. A note option I'm not finding. Okay, let it be. So our first problem would be from where we have to start finding the issues. It's very easy. I told you, mechanical structure, you don't be worried. Once it is installed, trials have been taken. Generally, we don't face any problem in mechanical structure. If machine gets shut down, we have to concentrate on three parts. And what are the three parts? Input of the machine, controller of the machine, and output of the machine. So we have to concentrate on three parts only. Let it be, it's very large, no problem. So you have to see first input side. We can have problem in input side. And in input, I have already shown you. We can have switches, we can have sensors, we can have many things. We can have problem in output side. So in outputs also, I told you motors, relay, contactor, solenoid valve, indicators, pneumatic hydraulic system. Pneumatic hydraulic system is those solenoid valves I have already told. So we can have problem in input side or output side. So it's very easy now. Okay, we will go and we'll check inputs. We will go to outputs. We will check outputs and we will reach to the problem. But still, there is one issue. In one good automatic system, in one good automatic machine, we might have 200 inputs. We might have 300 inputs. We can have 50 outputs. We can have 30 outputs. We can have 100 outputs also if it is spread in large area. Now, is it possible to go to each and every input and check where is the issue? It will take time. Obviously, it will take time. So it is not the correct way. But still, we have problem in input output. So we have not to be worried about all the things. We can concentrate on those things. So here you see, we have issue that we have large number of inputs outputs in one machine. In one small machine also, we have many inputs outputs. And generally, it's very difficult to find out the issue there. So what can we do? We can take help of controller. We can take help of controller. Okay. Now I shall have one small discussion about conventional controller, and then we'll come to PLC. Very first, when industry started, work started, obviously it was all manual operation, correct? It was all manual operation. Manual operation means there also we had inputs, we had outputs, and we had a controller. But who was the controller? A man was the controller, correct? A man was the controller. So a man was taking decision. What is the role of controller? Controller will monitor the system and will take decision also. So a man was taking decision. A man was monitoring. Suppose a tank had to be filled to certain level. So a man was controlling the outputs, like a tap was open, and he was monitoring also. So as level reaches to the certain point, certain level, he had to close the tap. So a man was the controller in manual operation, but it was obviously not accurate. It was time-taking system. Leave that. All these things you have discussed already in previous sessions. So manual operation was not that good. Obviously, it won't be. In industry, very first automatic controller came was relay logic controller, correct? Relay logic controller. Relay logic controller, what we had in relay logic controller? Relay logic controller was a very large, complicated electronic circuit, you can say. It was full of wires. You can say the logic means the sequence of operation. It was developed, it was designed using wires, electrical and electronic equipments, correct? So the logic was designed through wires and some electrical and electronic devices. So it was very large. You can see some pictures also I have shown you on screen. So it will have many equipments, components inside it. It will have full of wires. It will be full of wires. And initially it was that large, you could go inside that. It was that large. So the problem, what was the problem? This was automatic, not of that level of automation, but it was automatic. We had some issues. What was the issue? There were two issues there. And the issues were, first thing was, once you design one relay logic for one application, it was difficult to modify that for another application. So if you have to make slight modification even, it was very difficult. Then another problem was, if it is shut down, it was so difficult to find out the issue because it was full of wires. It was that large, you could go inside it. It had many electronic components. It had a relay contactor, it had a hardware timer, hardware counter, all these things. In some old machines nowadays also you can find relay logic controller. Okay, let it be. So we had issues in that. One example I want to give you, as most of you are from academics, you have seen relay logic control. You have seen motors in your lab, correct? You have seen motors. Any branch people, you have seen motor somewhere in your lab. And to that motor, you have seen you will have two push buttons. I had shown you push button, correct? I had shown you push button in picture also. So green color and red color push buttons you have seen. What is the property of push button? The property of push button is when you press you will get continuity, you will get signal, correct? But it has a spring system. As you leave the push button, what will happen? The push button is off, you can say, correct? The push button is off. Once more, push button has a spring system. When you press the push button, it will give you continuity. But as you leave the push button is off, means you are not getting supply through the push button now anymore. Now I come to the application. When you press the push button, motor starts running, correct? Because it gets supply. But have you noticed you are not going to press the push button for long? You're going to leave it also. As you leave the push button, what happens? Motor does not stop. Motor keeps running. So you can see the start push button is off, but motor has still been running. How? And you will see there is no any microcontroller or any kind of electronic controller, programmable controller connected to that. There is no any controller there, electronic controller. But you will find there is a relay there, and through one relay, using wire and relay, we make a latch. We hold it. So that is actually relay logic control. So when you design your logic using wire and using electronic equipments, that will be relay logic controller. I hope you understand it. Fine. Then next controller, everyone knows about that because it is the famous and very frequently used controller in academics. Nowadays also it is in syllabus in any university, in IIT, NIT, IIIT, in big universities, in your college also, everywhere, microcontroller is the main controller, correct? In academics, microcontroller is the main controller, and often students will do project on that. It is a good controller. In microcontroller now we have advanced version Arduino and all. So microcontroller is a good controller. How? Because it is very small in size, very compact. It is very cheap in cost also. In few hundred, now Arduino you can purchase in 300, 400. The best part of this controller is you can program it. As per your requirement, you can write your logic and your controller will work. If you want to change the logic, you can change it also. But let me tell you, the reality of industry, in industry, microcontroller is not the main controller. Or you can say microcontroller, I have worked, I do project, I have done project in many industries. Nowhere I have found microcontroller as the controller to control the production line. In some devices, some small applications, in some supporting devices, I have seen. But microcontroller you won't find in any mainstream industry. I have not found it. And I shall give you reason because sometimes academic people, we have some conversation also. Often I have faced the situation that they say that I promote PLC, I say something wrong about microcontroller. It's not like that. Microcontroller is a good controller, I told you. But we have some limitation that we don't use in industry. And I shall give you the practical things because in internet, when you search PLC versus microcontroller, many points, many conversations you will find. I shall give you the main reason. First, small reason, it is not a big deal, but there is one small reason. It's programming language. Programming language, it is based on C programming. And obviously, it's not that easy to understand, to learn. But yes, we can learn it. We will give time and we will learn it. But I want to ask you, your students do project on microcontroller. How many of your students make program for that project himself or herself? For microcontroller, we just go to Google, we copy the code, we make some slight changes, and we dump to the microcontroller. Most of time I have seen. So in academics also, what we learn about microcontroller programming is not that enough to make program for a big machine. But yes, we can learn it, I say. I come to the main reason. Come to PLC for a moment, and again I shall come back to microcontroller. In industry, when we go to troubleshoot any machine is out of order, they call us, okay, this is not working, find out what is the issue and restart the machine. So what we do exactly, we take our laptop with PLC software. We take our laptop with PLC software. Imagine one machine. So we go to the machine is out of order. We open the control panel. Control panel means where you have your controller inside it. So we open the box, that control panel. We take a communication cable of PLC. One end we connect to our laptop, another end of the cable we connect to PLC. Now, open the software, PLC software. In PLC software, we have option receive, and we call it upload also. See, in microcontroller, upload means you are sending program. But in PLC, upload means we are receiving. So I shall use send and receive. So we have option receive existing program. So we make PLC power on, and in software we have option receive existing program. We click it. In fraction of second, existing program copy will come to my laptop. Is this feature available in microcontroller? You are from academic, you teach microcontroller. Tell me, do we have option to receive existing program of microcontroller or Arduino? We do not have. So we cannot receive existing program of microcontroller. And it is not like that when we go to one industry, its program is already stored somewhere. So it is possible that we don't have that PLC program or that microcontroller program. Okay, next thing you see. After receiving program of PLC, we have option monitor mode. And as we click monitor mode, we can easily see, we can easily monitor the flow of supply, why my motor is not running, why this pneumatic system is not working, what is the problem, why supply does not reach to that. Everything we can monitor easily. In 5 minutes maximum, we start the machine. So this feature we don't have. Okay, let it be. Now I come to the microcontroller. So I told that it's programming language. First we face problem in that we can learn. Next problem I told, receiving program option is not available. So we can't receive program. Monitor mode we have in Arduino, but that monitor mode we cannot use to troubleshoot machine because of language. But I must say you, the feature what have been given to PLC, those features could have been given to microcontroller. But it's all marketing, business. When you get any innovation, you don't get that innovative part or innovation in existing system. With innovation, they will launch one new product. Like when you purchase a car, when any innovation comes in automobile, they won't give you that feature in previous model, but they will launch another model with higher cost. So that is the thing only. They did not give the feature to microcontroller. All new features they gave to PLC. And they launched new product, one small PLC of 8 inputs, 8 outputs. Also, if you say branded one, it will be 30,000, 25 to 30,000 minimum. Non-branded can come in 10,000. So you can see how like microcontroller and PLC, we can distinguish. Leave that business part, we come to the technical part. So I told you the technical reason why do we go with PLC. Those are the very important point. If anyone asks you why PLC we use, why do we use PLC in industry and why don't microcontroller, that technical reason you can say, business reason you don't discuss. Okay, fine. Now I come to the part PLC, programmable logic controller. So it's 1037. Okay. Programmable logic controller. You need to understand few things about PLC. Programmable logic controller. This is an electronic digital device. Concentrate, please, because each and every word will be important here. PLC is an electronic digital device. Definition you will have many in internet and all. Simple thing we will discuss in the simplest way. So it is an electronic digital device, very first, which take input, generates output according to the logic developed. It's the feature of controller. It's the work of controller. Controller will take input from switches and sensors, will generate output, but that output will be generated as per the program you have made. So PLC is an electronic digital device which takes input, generates output according to the logic developed. The point you have noticed here, it's electronic digital device. What does it mean? In simple, if I say we can connect only digital inputs, outputs to PLC. Digital outputs, inputs means the inputs, outputs which are either on or off. Very simple. Digital, 0 state, 1 state. So the inputs, outputs which has 2 states, on and off, that we can directly connect to PLC input output terminals. It means we cannot connect analog input output to PLC. Analog input means the temperature transmitter, flow, level, light intensity, luminous intensity. So such analog input or analog transmitter we cannot connect to PLC input directly. Analog output also we cannot connect to PLC output terminal. Analog output drive you can have. You can have vibrator. You can have control valve. Solenoid valve is digital, on and off. Control valve is analog because control valve will have percentage open and close. So 10%, 20%, 30%, as per your requirement, you can operate it. Okay. But you will find some PLCs which will have few analog terminals also on its main unit. 2 analog input, 2 analog outputs, like that they will give. But those PLCs generally we don't use for big project, because in big project we have many inputs, outputs, analog and digital. So generally those PLCs having few analog terminals won't be used in big projects. But we have few PLCs which will provide you some analog input output terminals on its main unit. So I told you it's a digital device. We can connect only digital inputs, outputs. But what about analog input output? For analog input output, we need to purchase analog input module, analog output module. In academics, we have ADC, DAC, analog to digital converter, digital to analog converter. So that module of the same brand you need to purchase, you connect to the PLC. So then you can connect your analog input. Fine. Now I come to the diagram of PLC. And understand, look at the screen. No need to note down. Recording will be given to you, I think, after training. And few things I shall share. Not all, but few things I shall share with you. So concentrate to understand the things. When I shall tell you to note down, then you note down, not now. Look at the screen, please, everyone. That anode system is not coming. Anode we cannot use here. Okay, let it be. I hope you can see the cursor here. So PLC block diagram. Let it be any brand of PLC or any type of PLC, like compact PLC or modular PLC. PLC will have some important components inside it. Parts, you can say. Very first, you can see it is power supply. Look at the screen, please. And I shall ask you some questions also. You need to answer. And your doubts you can type also. When you need your doubts, you can type in chat box or in WhatsApp, you can text. So power supply. For any PLC, we need to power it on, and power supply will be, and you can say everything will be manufacturer decided. We cannot decide anything. So power supply will be decided by manufacturer. Power supply we can have obviously of two types. AC power supply, DC power supply, correct? Yes, AC power supply, obviously, I shall finish this in 15 minutes, concentrate. Power supply, if we have AC power supply, we can take line, neutral, earth from one socket, correct? At our home, we have socket. In our college, we have seen socket. So from socket, we can connect one wire and we can give it 230 volt AC. You need to answer and you have to text it in chat box. What about DC power supply? And let me tell you, in industrial automation, DC voltage we use 24. So 24 volt DC will be used when you have PLC. So if you have to power on PLC with DC power supply, you have to provide 24 volt DC. In microcontroller, standard voltage will be 5 volt DC. So you need to tell me and answer it fast, please. What is the source of 24 volt DC? Like I told you, 230 volt AC we can provide from the socket. What is the source of 230 volt, 24 volt DC? Answer it fast, please. Everyone. What would be the
sir.
source? Yeah.
Transformer based power supply or SMPS can be used, which can convert 230 to 24 volt DC.
Okay. Other people, can you text it in Zoom chat room? Can you tell me? According to you, what would be the
or even batteries can be used?
Okay. Other guys, you know that. What's your name?
Professor Suresh Balpande.
Correct, sir. Other people, very good. Nehal, sir, you have told transformer. Mani, sir, you have told battery. Very good. Okay. And please feel free to share your view here, because there is nothing to feel hesitation here. So we are not in teaching and learning process. We are in discussion process. So it's not, I'm not a teacher. I'm not teaching you. Be very clear. I am sharing my experience. You share your experience. So don't feel hesitation to share your view here. And it would be good if you answer the things. It would be very interesting. So 2 people have replied. Very good. Next time, I hope more and more people will reply. So you have told transformer or any converter which converts AC to DC. That is correct. In college, we use RPS, correct? Regulated power supply. RPS you use, no? 0 to 30 volt you have there. So there you can set 24 volt DC that we can use. But in industry, we do not use such type of devices. In industry, we use SMPS. You were correct. SMPS, switch mode power supply. Note this down if you want. Switch mode power supply. And this is very important. Switch mode power supply. And why do we use switch mode power supply? Why don't we use RPS? There is one reason. When you use RPS, you provide 230, it will convert it into 24 volt DC, correct? Mute everyone. Today I don't want any. Admin can mute everyone, correct? Admin can mute everyone. Okay. So, see, if it will happen, I will forget the thing. What was that? What was I saying?
RPS.
RPS. So when you provide 230 volt, it gives you 0 to 30 volt. In RPS, if you get fluctuation in its 230, you will get fluctuation in its DC also. And fluctuation we cannot provide to electronic devices, or else after some times it will be out of order. So we use a SMPS, switch mode power supply. There also we give 230 volt AC. It converts to 24 volt DC, but it will give you continuous 24 volt DC supply. If you get small fluctuation in its AC, it won't give you any fluctuation in its DC, because that circuit has been designed accordingly. So switch mode power supply will be used in case of any controller you use. Like for 5 volt DC also you have SMPS, for 9 volt, for 12 volt, for 24 volt you have SMPS. So use SMPS from now onward. Fine. So I told you the difference. In college we have microcontroller, in industry PLC. In college we use RPS, in industry SMPS. Okay, such things will come more further. Okay, next is low voltage. Actually, this low voltage we do not provide from outside. It is internal. What is this? As it is digital device, its internal operation will take place on 0-1, correct? Internal operation will take place on 0-1, like your computer, your laptop, or any electronic device. So PLC internal operation will take place on 0-1. What is this 0 and what is this 1? It has existence also. It is imaginary, but it has existence. 0 means 0 volt DC. 1 means 5 volt DC. Nowadays, it is 3.3 volt DC also. So PLC requires 5 volt DC also for its internal operation. So whatever power supply you provide, it will convert that power supply into 5 volt DC and in 24 volt DC also for its internal use. So 5 volt DC generally you can say is low voltage inside PLC, which will be generated by PLC itself from main power supply. You do not need to provide from outside. I hope it is clear. Next, CPU. Obviously, CPU is going to handle all the things. It is the main part of PLC. Processor name will be different for different brand, that you need to check in its catalog, like Mitsubishi, Allen Bradley, Siemens. You need to check its catalog for its processor name. Main thing is here input output. We will have a slight more discussion about these two. Generally, we think that input output means sensor, switches, relay, contactor, motor. No. In block diagram, if I have shown you input output, in block diagram, if you see input output, it does not mean I'm talking about the physical existence of input output like sensor, motor, relay, like that. Not like that. Input output means on any PLC, we have input terminals, we have output terminals where we connect input output wires. Correct? I hope it is clear. So I'm talking about input output terminals, not the physical existence of input output. Now it is important to know about input output terminals, and you note down, please. Everyone note down. This is important, and this is the question of interview also. So you need to tell all these things to your students. In interview, they will ask this for sure. So they will ask you how many types of input outputs we have. Input output terminals actually. Note down. Initially, we had 3 types. three types of input output terminals. Relay type, note down relay type. Second, transistor type, relay type, transistor type. And third one is track, TRIAC, track. So we had three types of terminals. Nowadays, we have only two types. When you purchase a PLC, you will have to ask them, I want a relay type PLC or I want a transistor type PLC. Okay, is it clear? So input output terminals, you will have either relay type or transistor type. If it is relay type, all relay, all inputs outputs relay. If it is transistor, all inputs outputs transistor. Okay. Now where do we use relay type and where do we use transistor type? In general application, you can use either relay or transistor, no problem. But transistor type has special application. When you have high speed input or high speed output signal, when you have in your project, when you have some inputs which generates high speed inputs like high frequency input, very fast, on off like that. And if you have some outputs which needs high speed or high frequency output signal, then you have to go with transistor type PLC, not relay type. Relay will not sense or will not take or not generate high frequency pulses. Okay, one example I shall give you of a high speed input and high speed output signal. Where do we have? In your project, many times you have motors, and suppose there is one application, motor is running, and I want rotation feedback from motor. Listen carefully, and I shall ask you some questions. Motor has been running, and I want number of rotation feedback from the motor to our PLC. Suppose the application is, we start the motor, and when motor rotates, its shaft rotates 200 rotations, stop the motor. Got this? So I want the number of rotation feedback from the motor. Text me, please, everyone this time, everyone. How many people are there? 51. I think among 51, 20 people won't be attending, just they are logged in. So other 30 people, please text me, at least 25. Which device do we use to take feedback signal from motor? Which device we use to take rotation feedback? Device name.
Encoder, sir.
Tachometer, encoder.
Encoders.
Okay. Another guys, another people. How many are attending? If you are attending, please answer. Whatever you know, you answer. No problem.
We can keep even revolution and counter also, sir. Either
Okay,
maybe
very good.
encoder or revolution and counter.
Correct. Very good. So, Nehal sir, very good.
Hall effect sensor also can be used.
Okay. See, if we talk about tachometer, try to understand what is tachometer. Tachometer is a display, isn't it? Tachometer is a display. Why? You put this to shaft, it will show you the number of rotation per minute. But we want feedback. Feedback means what? Feedback signal I am talking about. Feedback signal means on-off signal I want. Digital on-off signal I want. So tachometer won't generate any on-off signal. It will just show you the things. But encoder, correct? We have different types of control encoder. Encoder is the device we use for taking feedback of motor. So that encoder will be disk kind of structure. This is put to the rotating part, and that encoder will generate number of pulses. Pulses means on-off signal, high frequency on-off signal. So it's not like for one rotation, it will send you one signal, one on or off. For one rotation, it might send you 36,000 pulses. One rotation only, and you are going to 200 rotations or many. So you can see in one rotation, you are getting 36,000 pulses. That high frequency on off signal, one relay won't take. It will show you 1, 2, and it will be gone. So relay won't read that. Transistor will read this. Okay, done. This is the example of input. And another people, you told some sensors we can use, like we can use proximity sensor also to the shaft. We can put some metal and we can put one proximity metal detector. As it will rotate, for each rotation, it will be on. For each rotation, it will be on. So that will also be high frequent because that motor is running with speed. So this sensor will be on off very high frequently. So pulses will be generated, won't be taken by relay. Okay, I go for the next example. I will have to do it fast because programming is also a lengthy topic which will take time. So another example of high speed output. In college, we use one motor, stepper, correct. Stepper motor we use. Stepper motor, you know, stepper motor. Stepper motor will not run by just on off. Like it's not like you give it 24 volt DC or 230 volt DC, it will start running like a induction motor. No. This requires number of pulses. Suppose for one rotation of stepper motor, it requires 100 pulses. So your PLC output should get on off 100 times, correct? So pulses should be generated. It's not just PLC output is on, your stepper will run. It requires number of pulses, on off signal, high frequency. So for that also, you will have to use transistor type PLC. In college, we use a stepper for the same application. In industry, it is servo motor. That when you will see Mitsubishi servo motor, I had seen it had 136,000 pulses for one rotation. So kind of high frequency pulses will be required. So there you have to use transistor type. So it is clear. Let me move. Memory, we have two types, program memory, data memory. And obviously the memory is E square prom, electrically erasable. So when you send new program, previous will be erased, will be deleted itself. So program memory is the memory location where your program will be stored, correct? You make program in software, you send it to PLC. So the location where it is stored is your program memory location. So the program memory is the memory location where your program is stored inside PLC. Data memory. Data means addresses. Addresses that we use in our program, like input address, output address, timer, counter, many things. Data memory is the memory location where all addresses are pre-located, means it is already there. Already it is located there, that we use in our program. So data memory is the memory location where all addresses are stored. Communication port. Obviously, to communicate our PLC with other devices, like first device is your laptop or computer to send or receive program. So PLC will have some communication port on it through which you can connect another devices like computer, drive, HMI, other things. Now on PLC, you will have minimum one, obviously it would be, but it can be more also. If you have more communication ports, your cost will increase, PLC cost will increase. So such type of communication ports you can find, you can see Ethernet port also, Ethernet port you can find 232, Ethernet port you have RJ port also we call it. Then you have 9-pin. This we find in old computers also. It is RS232. Then RS485. You can have RS422 also, that is round pin, round port, 8 pins. Some other communication protocols also are there, like Profinet, Profibus, but Profibus is a patent of Siemens. Then 485, DH485 is for Allen Bradley. It's a patent of Allen Bradley. So generally, if you have 485, it will be called RS485. So you can have any communication port on any PLC, and 232, 485, 422 means it has pin configuration like that. Okay, fine, that is it. Next, last part is extension port. On any PLC you will find extension port. Extension port is used to extend the physical capacity of PLC. Physical capacity of PLC. Physical capacity means you have one PLC which has, suppose, 8 inputs, 8 outputs, but you require some more inputs, outputs also. So if you want more inputs, outputs, then you need to purchase input extension unit, output extension unit, and that you can connect through extension port. In series, you can connect many. Another is ADC, DAC, analog to digital, digital to analog module. Those modules also you need to connect to PLC. That also you can connect through extension port, correct? So extension port is required on any PLC, and that is used to extend the physical capacity. Okay. Next. Okay, this slide is over. Now I shall come to programming part, and very fast we have to move because we have very less time. I hope you can see whiteboard. Now you see. Before I start programming, let me tell you, PLC has 6 programming languages. Among 6 languages, ladder diagram is frequently used. Ladder diagram is very easy to understand. And one thing I say often, that if you are interested to learn PLC programming, you don't need to be an engineer. Anyone can learn PLC programming. It is that easy. And ladder diagram is that easy, you can say. Other languages are also there. For any brand, they provide you option like 6 languages they provide you, or 3 languages they provide you, or 2 languages they provide you. But ladder will be there. Ladder is available with any brand. With ladder, some other languages like FDP, what we call it, STL, IL, and block diagram also. So there are 6 languages that I will tell you. Suddenly I forgot it. So I was saying that ladder will be there, but other languages will also be given. But it is not like that all 6 languages will be provided by all brands. No, they can provide you 3 at least. 3 languages they will provide, but ladder will be there. It's very easy to understand. If I say about ladder will look like this actually, you see. Isn't it a ladder? Step ladder. It's a ladder. This is one network, you can say. This side, these are network. These are network. We call it network. And this is your ladder. This is your ladder, or we call it rung also. In some PLC software, it will be called rung also, no problem. So either ladder we call, or we rung, or we call it rung. So in each network you will have one ladder. You can see in this network, you have one ladder. In this network, you have one ladder. In this network, you have one ladder. There is one rule. In one network, you can have parallel connections. You can have many parallel connections. As many you want, you make them. But you cannot interconnect two networks. Although in Siemens new software they have allowed, but generally in any brand, you cannot interconnect two networks. You can see network 1 and network 2. You cannot interconnect two networks. Okay, fine. I shall come to this again, but just one overview I have given you here. Before starting PLC program ladder diagram, I shall go through 2-3 basic electrical diagram. And why? Because it will help you to make PLC programming or ladder diagram very easily, believe me. So if I shall come directly to ladder diagram, some people might get confused. So I don't want that. I want to start from scratch. So very fast, you people need to answer and you need to do some assignment very fast. 5 minutes I shall take for this. Answer fast. What is this for? You can text me. Text it fast. Text it. What is this? This is a socket. This is a socket. What is this for? Text it. Text it fast. We have to go for earth. Okay. Text it fast, everyone. Yes. Okay. And let me tell you one thing about this very fast. It can be earth or ground, correct? But let me correct this. In terms of AC power supply, it is earth. In terms of DC power supply, it is ground. Be very clear about it. Okay. Next thing you have to answer, this left side terminal, what is this for? This left side terminal, what is this for? Text it fast. Left side terminal, live phase, correct? Everyone, don't feel hesitation. You type, please. Yes, phase, live. Okay. See, it can be other line or neutral, correct? It can be other line or neutral, but we have international standard. We have international standard, and see, always remember from now, always right side is line, left side is neutral. Always remember this. This is important. And I had sent one student for one interview. He had experience of 2 years, and he was asked this question. He was wrong, and he did not get the job. See how easy thing was asked. So you remember this. Right side is line. When you purchase new socket, it will be written on that. Right side will be line. Left side will be neutral. Standard. This is the standard. Okay, let it be. Now, you have seen a switch. You have seen a switch. How many terminals do we have behind one normal switch? How many terminals do we have behind one normal switch? Yes, very good. Very good. So we have 2 terminals. Exactly. Nice. So we have 2 terminals. Now I come to this. Home appliances. Home appliances are single phase. Let it be a pump, let it be AC, fridge, TV, or lamp, fan, anything. It is single phase. Single phase means one line is required and neutral is required. Correct? Single phase will require one line and neutral. 3 phase will require 3 phases and neutral. Okay, let it be. So I'm talking about home appliance. I have taken one example of lamp. We ignore earth, and I give you 2 minutes. Note down the same, and this is compulsory for everyone. Note down these diagram. Exactly, you note down exactly the same. Note down socket, note down switch, note down lamp. Connect these 3 things. 2 terminals, line neutral, 2 terminals of switch, 2 terminals of lamp. Make wiring diagram so that this lamp can be operated through the switch on off. Make the diagram and send it fast, please, because I don't have enough time. Draw it, please. On your notebook, draw and send it in group. Draw it on your notebook, send this in WhatsApp group. I shall check that. Draw this and send it in WhatsApp group. Draw and send it in WhatsApp group. Make it fast, please, because I don't have enough time, because in programming also it will take a lot of time. Draw it and send it. I shall check it. It should not take that much time. It's very easy. Draw and send it. I'm waiting. And it has no relation with any branch. It's not like only electrical people has to make it. This is very simple. Mechanical, electrical, instrumentation, EC, all have to make this. Very good, very good. Suresh sir, very good. Other people, make it fast, please. Draw it and send. Very good response. Vilas sir, very nice. Send it, send it. Very good work. Make it fast, please. All are not drawing, I think. Okay, let it be. Now I cannot give more time for this. I shall come here and will draw this. See, sometimes, and many times actually, not sometimes, most of time, some electrical people also do this mistake. I told two terminals, two terminals, two terminals. What they do generally, two terminals, two terminals, two terminals, and two terminals. This is right or wrong? Text pick. Right or wrong?
Wrong, sir. It will short.
Yes, it is wrong. Actually, we should not do this, because inside a switch we have one contact. As you will press the switch, you can see. Ignore this. Ignore lamp. You can see. You have short this line neutral, and circuit will be burnt. Don't do this. So if you don't know wiring, don't do that at your home. Don't try this at your home. Okay. So what we have to do, we have to connect our one thing. If I have a lamp and I have connected it like this, see, if I have a lamp and I have connected like this lamp will be on. If I have to off this, what shall I do? I shall just take and will break it. As I break one wire, lamp will be off. So what we have to do, we have to take we have to connect our lamp to line neutral, and we have to break this path. We have to break line path. In between, we have to connect the switch. In between, we have to connect the switch. Okay, if we have two switches, press other switch and lamp should be on. In that case, parallel connection will be there like this. I could have given you more time for this, but we have limitation, so I cannot give you. So I shall make this. So if you have two switches, you have to press any switch. It will be parallel connection. If you have two switches and you have to press both switches, then only lamp should be on. In that case, it would be series connection. How? Like this. So line will come to first switch, will go to second switch, and will go to lamp. So it would be series connection. Okay, let it be. I won't give more time for this. I shall come to programming now. Now you people concentrate. And I think, I hope that many people know about basic programming, but still I shall start from scratch and will come to some good examples. As I told, for PLC programming, we are going to use ladder diagram. It is one language, correct? It is programming language for PLC. And when we have programming language, we have to know about the instructions. Without instructions, we cannot do anything. So for PLC programming, for ladder diagram also, we have some instructions. Let me start from the basic instruction. Very first basic instruction we have here, contact and coil, contact and coil. Okay. Contact we have of two types. That is normally open contact, normally closed contact. Normally open, normally closed. Ladder diagram uses pictorial representation, picture representation, symbolic representation. So for NO, you have to use this symbol. For NC, you have to use this symbol. You can see. It's very clearly shown that this circuit is open, correct? Isn't it? See, this path is open. This circuit is open, normally open. Supply cannot pass through this. And this is already closed. Closed means connected. Already it is closed. So supply can pass through this normally. So normally open contact and normally closed contact. For coil, we use this symbol. For coil, we use this symbol. Now you see another thing. Simplify this. In your program, for input, use contact. This is basic discussion. So for input, you use NONC. To represent input, you use NONC, like switches, sensors. For switches, if you have to represent switch in your program, use its NONC. To represent the output, you use coil. Simplify it more. As I told, for input, you use NONC. When you have to get anything on, when you have to get, suppose, one motor on from the switch, try to understand. When you have to get the motor on from the switch, to get on, you have to use NO contact. So for on condition, you use NO contact. From the switch, you have to switch off something. To off, use NC contact. Got it? There are many things I cannot make you confused initially. So simply I'm saying you to consider now. To get the things on, use NO contact, and to get the things off, use NC contact. Is it clear? I hope you have noted this down, and I shall send you this picture in group. Just taking time. Okay, further I shall send you. Okay. Okay. So this you understand. NO, NC coil. NO we have to use when we have to switch on something. NC we have to use when we have to switch off something. Correct? Let me move. I shall remove this. Now you come to the PLC. This is a PLC top view. This is the top view of one PLC. On any PLC, we have input terminals like this. We shall have input terminals and we shall have output terminals. See, this I can show you in PPT also, but it won't be that effective. On PPT, people don't concentrate, I know. So you concentrate here. So here we have input terminals, output terminals. Important thing here you need to learn is these terminals will have fixed address, you cannot change it. These terminals will have fixed address, you cannot change it. And for different brand, you have different address. For different brand, you have different address. Like for Mitsubishi, it's X for input, Y for output. For Siemens, it is I for input, Q for output. For Allen Bradley, it's again I for input, O for output. So you don't be worried. For our programming practice, we shall use I for input and Q for output. Is it okay? So we shall consider input address is I, output address is Q. Now, as it is I, it is fixed that first input terminal will have address I0. You cannot change it. We cannot change it. Second terminal will have fixed address I1, then it would be I2, I3, like that. You will have addresses. The same for output. If it is Q, then first output terminal is Q0, second output terminal is Q1, then it is Q2. Like that, you will have addresses. Now, all your inputs will be connected directly. There is no parallel series connection. And this is not the exact wiring diagram. This is for reference only. This is not correct wiring diagram. So don't take it, this diagram, don't take this wiring very seriously. But concept I'm telling you, if you have your output or if you have some input, those are directly connected to PLC. There is no parallel series connection. There is no parallel series connection. So all your inputs, outputs will be connected directly. But just by connecting inputs and outputs to PLC, it's not like you will press first switch and your first output will be on. It is not like that. After connection, you need to send some program. If you don't have program inside PLC, your machine won't run. So you press the switches, nothing will happen. So you need to send program. So we start our program from here. First example, everyone concentrate and you have to reply, you have to send, if I give you some assignment, then only you will learn it. And it's my guarantee, basic programming I shall make perfect for you. So concentrate, please. Anyone can learn it. First example, very small example. I shall start with very small example and then we'll go for some big one. First example, press this switch, lamp should be on. Press this switch, lamp should be on. I shall say this in another way. Press the switch I0. Do you understand? Press the switch I0. Why I0? Because the switch is connected to I0 terminal. So press the switch I0, lamp Q0 should be on because lamp is connected to Q0. So when you make program, it does not matter what is the physical existence of input output. Let it be motor, lamp, fan, solenoid, anything. In your program, important thing is address, input address, output address. These things are important. Motor, fan, lamp, these are not important. So I told you, press I0, Q0 should be on in simplest way. Press I0, Q0 should be on. Let me draw this. Let me make a ladder diagram. Program, final coding I'm making. As we have to get the lamp on, I shall use an O. And here is Q0. And this is your final program. Nothing else to write down, no printf, scanf, nothing, no if and else. So this is the program for this simple example. Now, after making this program, I need to send this program to PLC. And then when I go to machine, I press this switch, this lamp will be on. I want to clarify a few things here. And see, you will be able to check your logic on your notebook itself, how you see this, how you can check your program on your notebook. Can you see this left line? Look at the screen, please. This left line. Consider this is the main supply. This is virtual. This is virtual. This is your software part. Be very clear. This is your real machine. This is your machine. This is your software. So virtually, this is your main supply. Left side is the main supply. So initially, what does this initially means? Initially means your machine is powered on, PLC is powered on, but you have not operated any switch. This is the initial condition, isn't it? Machine is powered on, but you have not pressed any switch. This is the initial condition. So initially, when you have not operated any switch, what would be the condition of supply? The supply will be up to this, isn't it? This main supply will be up to this contact. It cannot cross this. It cannot pass through this, because this is NO, normally open. This circuit is open. I hope it is clear. Once more, this is the main supply. And when you have not operated any switch, so initially this main supply will flow and will stop here, because this circuit is open. This contact is open. Now I go to machine. Now I shall go to the machine, and on machine I shall press this switch. When I press this switch, which address is high? When I press this switch, tell me, when I press this switch, which address is high? Text me fast. When I press this switch, which address is high? Are you people there?
Yes, sir.
So when I press this switch, which input will get high? Tell me. You need to answer. I know you understand, but you need to answer.
I0, sir.
I0 will be on. So text this. It's very simple process. I told you to text, you text, please. Okay, I0 will be on. Very good. If you text, I can understand, okay, you are there. So I0 will be on. So on your machine, you press this switch, I0 is on. So in your program, wherever you have I0, all I0 will get on. So in my program, here is I0. So when you press this switch, I0 is high. In your program, I0 will be high. So as this is high, what will happen? Now this will start conducting. I0 is on. Now this is conducting, and this main supply can reach to this Q0, and Q0 is on. Now as this Q0 in your program is on your machine, Q0 terminal will be high. As this Q0 terminal is high, connected output will be on. Let it be motor, fan, lamp, anything. So your output is on. Now switch off this. Now switch off this. Switch off this. So this switch I make off. I0 is off. As I0 is off, what will happen? This supply will again stop, and this output will be off. This output will be off. Done. So this is the concept. You can check your program on your notebook itself. So initially main supply is up to this. As it is open, supply won't pass. As you press the switch, I0 is high. As I0 is high, supply will reach to Q0. It is there. Next example, everyone note down and send me the ladder diagram. Note down and send me the ladder diagram. I tell you. Next example is, we are having two switches. Listen carefully, and you have to draw this. You have to send in group. We are having two switches, I0, I1. Two switches, I0, I1. One lamp, Q0. Press either I0 switch or I1 switch. Press any single switch, Q0 will be on. Make this program and send it. We are having two switches, I0, I1. One output, Q0. Press either I0 or I1, Q0 should be on. Draw this ladder diagram you draw and send to WhatsApp group. And make it fast, please, because we have to make many programs and I have only half an hour. Make it, please. Send it in group. Send it in group. Press either I0 switch or I1 switch. Very good. Vilas sir, correct. Nice. Press either I0 or I1. Q0 should be on. Correct. Suresh sir, correct. Swati madam, correct. Very good. So you understand it. And I think you know it from before also, but it's correct. So it's easy. Either you press I0 or I1. So I shall draw it now here, but very few people are making this. I expect more and more people to make it. Okay, so here, either you press I0 or you press I1. See, this connection, either you take from here, or you can take like I have taken, no issue. It depends on software, how does it allow. So here you can see I0, I1, and Q0. We shall check the supply here. We shall check the flow here. So initially, main supply is up to this, is up to this. Now we go to this one and we press this switch. I0 will be on. As I0 is on, supply will proceed, this will be on. As I off this is off, so Q0 will be off. Now you press I1 switch. When you press I1, this parallel connection you see, parallel path, this I1 is high, so this parallel main supply will proceed and will reach to Q0. Q0 will be on. Done? It is correct. Now, next example, and make it fast. We shall reach to the difficult one. Again, two switches, I0, I1, and one output Q0. Two switches, I0, I1, one output Q0. This time, press both switches, then only lamp should be on, not by single switch. Press both switches, lamp should be on, Q0 should be on, not by single switch. Make ladder diagram and send it fast. Send it fast. And I expect more and more people to send it. Press I0 and I1, both switches, then only lamp should be on, Q0 should be on, should not be on by single switch. Make this and send it. So Shekhar sir, correct. Very good. "60 participants and not even 20 replies I am getting." Suresh sir, correct. Sandhya madam, correct. You need to give I0, I1, Q0, correct. Very good. Gil sir, exactly correct. You give I0, I1. Okay, for certificate, I shall send some questions to the admin. Before that examination, you don't give certificate. I shall send you some questions. So people who will not concentrate will lose certificate. That is sure. Okay, done. So many people have made this. Very good. So this is simple. We have to do series connection, correct? We have to do here series connection. So it would be like this. It would be series connection. So I0, I1, and Q0. Done. Very good. So in academics and in industrial interview also, some questions will be asked regarding program. Make program for digital gates. So already 2 digital gate program we have made. What are the name of those digital gates? So parallel connection, which gate? Parallel connection.
OR gate.
OR gate, very good. And series is AND gate. See, parallel, this or this is OR gate. And this and this, then only Q0 is on. So series connection is AND gate. Can you make program for this NOT gate? In NOT gate, we have one input, one output. So the application, I shall relate it with one application. We have one switch, one motor. We have one switch and one motor. When you do not press the switch, see this, when you do not press the switch, motor should be on. And when you press the switch, motor should be off. Make this and send it fast, please. Everyone. We shall come to the big program also, but let us finish all these things. This is NOT gate, inverse. When you don't press I0, Q0 will be on. So you don't press switch initially. You can say initially when you don't press switch, motor will be on initially. And when you press the switch, motor will be off. Make this program and send it fast. Send it fast, please. Now we are getting good response. Very good. Very good. Okay, this time we got good response, better response than last example. Okay, I shall directly come to the solution. You are trying well, very good, everyone. See, not get, because this is important. Although everything is important, but you see here, you have made like this. So I0, Q0. We shall check it. We shall check this. So initially, your main supply, you have to check initial condition first. So this is your initial condition, right? I0 will be 0. Sorry. So the truth table is, it is 0, it should be 1. It is 1, it should be 0, correct? I0 and I1, I0 and Q0. So you can see here, when you don't press the switch, so PLC is powered on and you don't press the switch, output should be on. Check this. When you don't press the switch initially, this main supply will flow as it is connected already. It will flow and will reach to Q0 and your motor is on. So without pressing switch, supply reaches directly to Q0 coil. So this is the benefit of software. So through software, this main supply, virtual main supply, we send to Q0. As virtually Q0 is on, hardware Q0 will also be on. So initially, you can see initially supply reaches to Q0. Now, you press I0 to the machine. You press I0 switch. As you press I0, what will happen? As NO is on, it will conduct. But as NC is on, it will break. Correct? NC on, it breaks. So as I0 is on, NC will break the path. As NC will break the path, main supply will stop here and your Q0 will be off. I hope you understand. So this thing you remember, NO on, it will conduct. NC on, it will break. So NO2 on, NC2 break. NO2 on, NC2 break. That is it. Next example. And next example you make very fast. Oh, time is running so fast. Next example. So I might extend the session. So answer all examples. Next example is, there is one term, interlock. Interlock means client will give you some conditions to run the machine. Your machine should run for the given conditions only, not for any other condition. The machine should not run for any other conditions. Now you take this example, OR gate. OR gate. In OR gate, I am the client, you are the programmer. I told press any single switch, press any switch, and Q0 should be on, correct? It means when you press only I0, motor is on, or you press only I1, motor is off. So check this, when I0 is on, it is on, correct? It is off, it is off. When I1 is on, Q0 is on, correct? Off, it is off. Now I am client, I shall check interlock. I told it should be on by single switch. It means it should not get on by both switches. So if I operate both switches, what will happen? Tell me, text me. If I press both switches, what will happen? In OR gate, if I press both switches, what would be the status of Q0? Text me fast. If I press in this program, if I press both switches, I0, I1, what happens to Q0? It will be on, correct, very good. So it is getting on. It means, according to client, as per interlock, this program is wrong, isn't it? This program is wrong because client told you press single switch, motor should be on. Here you press both switches, motor is still on. It means it is wrong. Your program should run for the given conditions only, not for any other combination. So there is one gate, that is XOR, which is for interlock. So please make this program very fast. After this, I shall give you another example, which will have many inputs, many outputs. So I0, I1, and Q0. What is the condition? The condition is when you press only I0, Q0 will be on. When you press only I1, Q0 will be on. But when you press both switches, it should be 0. And another thing, when you don't press any switch, initially it should be off only. Make this program. After this, I shall share one trick. After knowing that trick, everyone will be able to make any program, basic program. So first, everyone, you please try this in 2 minutes, please. In 2 minutes, you send this program. Everyone, kindly. Whatever you know, you make program for this and send me. Let me remind you the rule. The rule is, if you have one output in this program, you should have only one coil of Q0. Don't take 2 coils of Q0. No. In this program, you have to take only one coil, no 2 coils. Okay. In this program, you have to take only one coil because you have only one output. But inputs you can repeat. I0, I1 you can repeat. So NO and C you can take many. I0, I1 you can take many times. But coil will be only one. Q0 will be only one. Make this please. Make this and send this. I know many people know this program. Send this fast. Send this fast. Som Shekhar sir, you have made for OR gate. You made for OR gate. Rahul sir, you have made for AND gate, but this is XOR gate. You are trying well. You are doing good. I told Vilas sir, we should have only one coil. You have taken 3 coils. We should have only one coil. You are trying well, sir. Very good. But Vilas sir, you check one more thing, that when you don't press switch, supply should not reach to coil. That is also you need to check. Very good. Very good try. So it doesn't matter whether it is right or wrong. You try this, please. Ashita, madam, Good try. Very good. Give address I0 and I1. Give address to the contacts, please. Ashita madam, you give addresses and send it again. Suresh sir, very good. I0, not correct, not correct. No, no, correct, sir. Correct. Very, very sorry. Suresh sir, correct. I know. Many people know this program. Sanjay sir, correct. Very good. I0, Sanjay sir. Correct. Sakshi, you have not checked 00. When inputs are off, output should not be on. But in your program, when inputs are off, output is getting on. And Ashita, 0. Now it is wrong, Ashita. I see. Please do not mind if I call you with your name because I don't know who is a student and who is faculty. So please don't mind that. So now initially it was correct. Without address, it was correct. But obviously
Yes,
we
sir.
need to give
Yes, sir.
address.
Actually, I0, I1 and niche 1, I1, I0.
But it should be opposite contact. Opposite contact. You have given the same contact. You see I0 NO, I0 NO. It should be one I0 NO, one I0 NC. Like that.
Yes, yes.
Yeah. That
And
mistake has been done.
yes, sir, yes. Okay.
You change
Thank
that.
you.
Gil sir, not yet correct. You're trying well. Very good. I'm very happy now because I'm getting response. So now I shall don't waste time, but I request you people to give me 15 minutes extension. Then only I will be able to share the trick. I hope it would be okay with you people. So let me come to the interesting part, tricks to make program, tricks. And believe me, everyone will be able to make next example if you follow this trick. I shall take XOR as consideration. This you do not note down because the tricks, the steps I shall send you. Understand. How do we make program easily? You understand. So don't note down, just understand. When we have examples where we have inputs, outputs, on and off condition, simple, no complication of delay, count, analog, nothing like that. It's simple example I'm talking about. When you have simple example, let it be any number of inputs, outputs, it has on and off condition only, no complication of delay and all. Easily you can make it blindly actually. How? I follow few steps. Those steps first I shall tell you, and then I shall show those steps with XOR. So what are the steps I follow? First, just I'm explaining this. You don't note down. Listen carefully. When you get any example, first of all, make a truth table. Make a truth table for the example. Once more, make a truth table. Then after making truth table, and what are the things in truth table? Inputs, outputs, and its conditions, correct? As you can see on the screen, you have XOR truth table. So input, output, and conditions. So make a truth table. After that, you started from NO and CNO. For a few examples, start from coil. Start from coil. It will help you. So make a truth table, go to the first output, and take a coil for it like this. So you can see I did not start from NO and C. I have taken coil directly. And I told, go to the first output. What does it mean? In some examples, you can have many outputs, correct? No, Q1, Q2, Q3, many. So when you make program, don't be worried about all outputs. You start from first output finish for first, then you think about second output. Don't mix. So again, make a truth table, go to the first output, take a coil for it. After taking coil, you think about that output will not for others. Check the true condition of those of that output. Check the true condition of that output and add the status of all inputs you have used. Let me show you on screen. Make a truth table, go to the first output, take a coil, check the true condition. Where is it true? Here it is, isn't it? Q0 is true here, on here. So when Q0 is on, what is the status of inputs? Inputs are 1, 0, 1, 0, isn't it? So when Q0 is 1, input you have 1, 0. For input 1, you take NO. For input 0, you take NC. I know it's complicated. Now I shall show you practically on screen and it will be very much clear. So don't note down, look at this, how you can make this easily. And next example you have to make. Next 2 more examples we shall make. Look at this screen. I'm going to follow each and every step. First step, make a truth table I have made. Go to the second step, go to the first output, take a coil for it I have taken. Now next, you concentrate here, you are confused. See this. Check the true condition of output. I'm going to check here. Here it is true. Check the true condition of output and add the status of all inputs you have taken. How many inputs do we have? 2 inputs. So all inputs we have to include. Once more. Check the true condition of output. Add the status of inputs you have used. And what is the status? 1, 0. So for input 1, what did I say you? For input 1, you take NO. For input 0, you take NC. And what is the status of this one? What is the address of this one? I0. So I take I0. What is the status of this input? I1. It is not over. Don't go to another output. Stick here only. Check the true condition again. Check the true condition again. So I'm checking it again. It is done. Here it is on again, isn't it? Q0 gets on again. When Q0 gets on again, what is the status? 0, 1, isn't it? 0, 1. So for input 0, what do we take? For input 0, what do we take? For input 0, we take NC. See this. This input is 0 here. So I have taken NC. Next, input is 1. So for input 1, I take NO. Connect to the same output because these 2 conditions are for Q0 only. So I connected to Q0. Again, what is the address of this NC? I0 and this NO, I1. Next, do not make program for 0 of output. Do not make program for 0 of output. If you will make program for 0 of output, program will be wrong. So make program for true conditions of output only. Do not make program for false condition of output. And if you are able to make true conditions, false will be satisfied already. So once more, I shall repeat and will give you one example. So make a truth table, go to the first output, take a coil. Check the true condition of output, add the status of all inputs. Don't skip any input. For input 1, you take NO. For input 0, you take NC. Make program for all true conditions in parallel. You see, this true condition also we have taken in parallel. Do not make program for 0 of output. I hope you understand. I hope you understand. So the steps I shall send you in group. And meanwhile, 2 more programs I need to make. One example I'm giving you, simple one. Then I shall complicate it. So make this, please. Everyone look at the screen. And if you want to note down, please. Note down, please. Note it down fast. Note it down fast. Make it fast, please. Is it done? I have sent it in WhatsApp group, the steps. It is not gone yet. Yeah, it is gone. So you can check in WhatsApp group, I have sent the steps. Once you go through the steps and try the same for next example, try the same for next example, please. I'm giving you next example on screen. We are having three inputs, listen carefully. We are having three inputs and one output, three inputs and one output. Three inputs and one output. I0, I1, Q0. Just a minute. Mukund sir, can I extend for 10 minutes?
Sir, definitely.
Okay, sir. So three inputs, I0, I1, I0, I1, I2, and one output Q0. I0, I1, I2, and Q0. And the conditions are simple condition. Among three inputs, you press any two inputs. Among three inputs, you press any two inputs. Output should be on. But output should not get on by all switches or not by single switches, single switch. Okay. So conditions you can have when you press I0 and I1. You can have I1 and I2. And you can have I0 and I2. So for all these three conditions, your outputs should be on, but not for other conditions. So do nothing blindly, make a truth table, follow the steps, and in 2-3 minutes, you make it and send it. Make it fast. Make it fast, please. Better you make a truth table first, and no need to make a large truth table. Only 3 steps in your truth table. Only 3 steps you make. No need to make 8 steps here. No need to follow all the rules. Just I shall also make the truth table for you. I0, I1, I1, I2, and I0, I2. That is it. This truth table is enough. Now you start from coil. Start from coil. Don't use mind, please. If you will use your mind, your program will be wrong. Just follow the steps I have told you. Make it fast. Very good response. Correct, correct. 2NO, 1NC, 2NO, 1NC. Nice. Sakshi. Correct. Somasekar, correct. You need to give address I0, I1, I2. Yours is correct. Then Ashish sir, 2NO, 1NC, correct. I1, I2, I1, correct, correct. And Sandhya madam, correct. Very good, very good. So follow this step, you will get solution. Follow the steps, you will get solution. One more minute. Other guys also, please send the program. Other guys too, send the program, please. Ashita, correct. Gil sir, correct. Vilas sir, correct. Very good. It's nice. Okay, so I'm sure you people understood the steps, but I'm very sure that in next example, you will use your mind and you will make mistake. I have seen many times. Why? Because we get overconfident. So we don't need to be overconfident. If you want to make program correct, next example, then please just follow the steps. Do not use anything extra. You don't use mind, I will say directly, and your program will be correct. But if you apply your own logic, then it might be wrong. So I shall go for next example. Look at the screen, everyone. This time we are having two inputs, I0 and I1, three outputs. This time we are having three outputs. See, yet you have made for one output, correct? No? So one output, you have taken coil, all true conditions you made. In the same way, you go for next output, take another coil, don't relate with previous one. Take another coil, separate coil, all true condition you add, done. Go for next coil, take coil, all true condition you make, done. If you will relate one output with previous or another, it will be wrong. So three outputs. What are the outputs? The outputs are blue lamp, green lamp, and red lamp. Conditions. When you press I0, only green lamp will be on. When you press I1, blue and green both will be on. And when you press both switches, I0 and I1, only red will be on. Make this program, please. But again, I shall tell you, just follow the steps. Same steps will be followed for all three outputs and take separate output. Only three outputs we have. So three coils only we will have. No interconnection of outputs. Separate outputs you should take. No parallel series connection of output. Make this, please. Manish sir, correct. Previous one you made, it's correct. Make new program. I have given on screen. Is it done? Very good. Who is that? Shakshi Madam. Correct, correct. Exactly. So you did not use your mind and your program is correct. Next person, send it. And try to make your own. Don't see others' solution. Because it will help you to make next any example you make in future, it will help you. So make it yourself. Everyone try this, please. Only one person has sent. Other people, what are you doing? We have not to repeat the address. Make it one by one. Blue is getting on once, green is getting on twice. That you have to see. Some people are using mind. So if you apply some logic from your side, it would be wrong. I told you, no interconnection of outputs. If you interconnect, it is wrong actually. You can see, who is that? Ashish, sir. You have tried well. But you see, when you press I0, only blue should be on. But in your ladder, blue and green both are getting on. So I told separate output you take. Don't relate one output with another one. Make logic for each output. Then it would be correct. You're trying well. Very good. Other people, make it fast. Already we are running out of time. Make it fast. Ashita, madam. How many outputs do we have? Only 3 outputs. So we have to take 3 coils. If you start making program from NONC, your program will be wrong. Better you start from output. See, some people are making mistake. I had told you before giving this example. Some people will make mistake. Series output we cannot take. Series output we cannot take. Not allowed. And Sanjay sir, very good, correct. Very nice. Suresh sir, see one thing. I told for each output you take all inputs. If you don't take all inputs, there is a problem. You have taken only NO. When you press both inputs, Suresh sir, when you press both inputs, what will happen? All your outputs are getting on, you can check. So NC must be there. So take all inputs. You have taken only one condition. You have to take zero condition of input also. So you have taken one condition of input. You have to take one condition and zero condition both of input. So you have taken only NO, NC will also be there for green and blue. Try it once more. Sandhya, madam, correct. Very good, you see. It's correct. Now, money, correct. Shantanu, correct. Vilas sir, we have three outputs. So we should have only three outputs coil. You have taken four. You are relating one output with other. You don't relate, separate. Like for green, you have tried. For green is getting on twice. So first you finish for green, then you go for blue, then you go for red. So separately we have to make. You're trying well, very. Okay. Gil sir, correct. Very good. So see, it's very easy to make this program if you follow these steps I have told you. See, this is not a rule. For making program, there is no rule. My logic can be different, your logic can be different, others can be different. So there is no fixed logic for one program. But I tried to make it simple. Like if you follow these steps, I think anyone can make program. See, if you made any mistake, that is not a big deal. But I understand that you got the things, you got the logic, what we have to do. Some mistakes are obvious, no problem. So here, let us make this last example all together on screen. Look at the screen, please. Okay, look at the screen. So what I told, take, make a truth table, already made. Mistakes where you are making, I shall tell you this, that you look at the screen. After making truth table, go to the first output, take a coil for it. I have taken. The important thing is when I'm making program for blue, believe me, I'm not seeing green and red. And your mistake was you were worried about green and red also at the same time. I'm thinking about blue only. Now I go for it. Don't think about other. Only blue you see. Look at the screen. Blue. Check the true condition. For zero, we have not to make. Here it is true. So when blue is true, what is the status of inputs? Here is the status of input. So you can see when blue is true, the status of inputs we have 0, 1. So let me take this. 0 means NC, 1 means NO. So you have taken here I0 and I1. One person had made that mistake that only they took, he took only NO. We have to take NC also here, correct? Next, check blue again. Blue, 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 it is done. So blue is finished. Now I shift to green, but what have you done? Some people, as they made this, they were seeing this also, and they made series parallel connection. That was the problem. So when you make for blue, make for blue only, don't think about green. Now I shift to another output. I shall take separate coil and we'll check green. True condition here. When it is true, what is the status of inputs? 1, 0. Check this. When green is true, 1, 0. So for 1, you have to take NO. For 0, you have to take NC. Connected. I0, I1. Next, Check it again. Again, it is on. I'm not thinking about other outputs. So green is on again. What is the status of inputs? 0, 1. 0, 1. It is for green only. So connect to this I0, I1. Check it again. Check it again. It is off here. So don't make. It is off here. Don't make. So green is done. Now I go for red. We'll take one more coil here, red. Check 0, 0, 1. So for 1, input status is 1 and 1. 1, 1. Connected to red. So it is I0, I1. Done. So if you follow these steps, program you can make very easily. Okay. So you can note this down if you want. And in the evening, I shall send one program in group that you try with the same, or not in the evening. After session, I shall send you one example, basic example, like this one. You try for that and send me in group. So I hope something you learned about PLC programming and you understood the block diagram of PLC. PLC has 2 types. As per its input-output terminal, that is a relay type and transistor type. As per its size, PLC is of 2 types. Initially, it was of 3 types: micro, mini, modular. Now it is of 2 types: micro and modular. That is compact and modular. So let it be. I hope you understood something. So I shall finish the things here because we have limitation of time. So like this, we have a trick for all kinds of examples, and programming is very vast. We conduct training, internship training, and you won't believe 6 hours per day, 1 month complete we do programming only. So it is a wide range field. Thank you very much. Keep in touch. I hope we shall meet again in some other programs. Thank you, sir. Holka, sir.
Thank you, sir.
Thank you, sir. Thank you very much for such a nice and you can say very informative session. I hope all the participants have gained some basic knowledge about PLC and PLC programming. So, on the behalf of Guru Gobind Singh Polytechnic and from all FDP team, we in fact very much thankful to Mr. Himanshu sir for delivering such a wonderful session. Thank you very much, sir.
Thank you, everyone. And one person has told for session recording that Holka sir will
Yes,
send
yes.
you.
Recording will be available on YouTube.
Yeah. And I shall do one thing. I shall share my one training program recording I have that is on programming. That also I shall share in group. Further, you can go through that. Okay. Thank you. See you all again. Thanks.
Just a
Thank you,
minute,
sir.
sir.
Thank you.
Good afternoon, all.
Good afternoon.
So it's kind request to please turn on your camera for the group photo with our respected guest. Everyone, please turn on your camera. Okay, done. Thank you so much, sir.
Thank you. We'll leave now.
Thank you, sir. For the participants, sir was present from the first day, and sir is also available to afternoon session also. So please, if you have any query, please ask in the afternoon session. Okay.
Second session will be start at 1 p.m. In that session, we will discuss about whatever we have learned during this first session. So the next extension part will be carried out in next session, that is in second and third session.